Welcome to the Staylock How-To Workshop. Today we're looking at the Sta-Lok Self-Fit Terminal. Before we start, let's talk a little bit about wire rope. Wire rope's available in different materials, different constructions and diameters, and conform to different international standards, both metric and inch dimensions. Wire ropes are also available with internal wire rope cores and fibre cores. Staylock terminals should only be used with stainless steel wire rope with an internal wire rope core and should not be used with other materials or indeed with fibre rope cores. Typical constructions are 1x19, 7-strand, which is 7x7 or 7x19, and compacted strand. They are all different constructions and require different wedge components when we start to look at the Staylock terminal. The Staylock terminal is an assembly of components, so let's have a look at those. I'll just take this fitting apart so that we can look at the individual components. We have the socket component, a wedge, a former, and the end terminal. So let's have a look a bit more at the detail of these components. The socket component has a machined taper narrowing at the end that the wire enters the fitting. The wedge is laser marked with the diameter of the wire and the construction. The former sits in the bottom of the fitting and the end terminal. There are a variety of end terminals and details can be found on our website. So today I'm going to terminate 8mm 1x19 using a Staylock terminal. The process is exactly the same as if you were terminating other diameters of the same construction or for different constructions. Before we get started, I always recommend that you remove any sharp edges for the end of the wire rope. We slide the socket component at the narrow end onto the wire rope and then open the outer strands. Wire rope is pre-formed and these wires will go back into their natural position. And we just take each strand off the core and you can see how easy it is now to manipulate those strands around the central core. We slide the wedge component onto the core strands of the wire and we then reposition the outer strands around the wedge. If we slide the socket component up at the same time, it helps to control those strands. And what we're looking to achieve is 3mm or 1/8 of an inch of the core strands protruding through the wedge. And we reposition the outer strands around. What we're looking to achieve is an equal distance between the individual strands. It's worthwhile spending some time with this because what we need to understand is that each of those strands is taking a load. And if they're all bunched up on one side, you will get an uneven loading on those strands. It's ready to put together. The former, which sits in the bottom of the fitting, as you can see, the outer strands sit neatly in there. And what will happen as we screw the fitting together is the former will rotate, keeping those wires in that fixed position. And it will also bend the wires over the end of the wedge, so it's completely captive. So once we're happy that the wire strands are equally positioned around the wedge component, we're ready to put it together. The former, as we said, sits in the bottom of the fitting, and it's a simple process of now screwing it together. This can be done with simple hand tools. Today I'm in a workshop and I'm using a vise, but equally it can be done in the field, on a marina, at the dockside or on the boat. So let's put that together. We screw the fitting together, simply screw it on. As we're screwing it together, there will be little resistance. But as the wires are formed over the end, it will come to a direct stop and you will feel increased resistance. There is no point and no strength gained by tightening it further. So there's no torque setting, there are no special tools required, but it's important not to over tighten the fitting. A good thing about the Staylock is that we can now take it apart and have a look at it to see that the termination is what we expect it to be. And as we can see, the individual strands are in the position that we set to start with, and they're nicely bent around the wedge component. That's the perfect termination. So important to understand, there's no torque setting, there are no special tools required, and we can check that the fitting is correctly terminated. The fitting is stronger than the wire rope, so the wire rope would physically break before it would pull out of the fitting. Staylock fittings can be reused under certain conditions. As we've seen, we can take the fitting apart and inspect the connection, the termination of the wire rope. Should you require to do some maintenance on the boat, the fitting can be taken apart and reused, but we would recommend replacing the wedge every time. The slit in the wedge closes up as you put it under load and grips the core strands, making it more difficult to take off, and it could potentially be damaged when you take it off. Loctite can be used on the Staylock fitting. It is a preference. If you want to put Loctite on, it will secure the fitting. It would be recommended on a rolling forestay or where you've got a rotational device going onto the wire rope. But it isn't an essential if the wire is static. If you are using Loctite, the Staylock fitting is supplied with an anti-seizing compound in the fitting, which is very effective, so you would need to clean that off before using the Loctite. Some people ask us if they should use a sealant in the fitting, and it comes down to a personal preference. If you are going to use a sealant, it needs to be non-acetic. Once you've terminated the fitting, put a blob of sealant in the bottom of the fitting and then screw it back together. You will then see the sealant coming through the end of the fitting. That's absolutely fine.